This is where we were, right? So I'm doing question number 1 in section 1.2. And we're talking about this. So we're talking about frequency tables. So we did this one. Let me do it again really quickly. So how do you figure out frequency? What are they talking about on this example? Does this make sense? I think. Let me do this. What if you had the following quiz question? Let me just make one before you, real quick, and then I think this will all make sense. How about after our first exam, when you guys are done with the first exam? What is that, in a week from Wednesday? And then I pass it back to you the following meeting. I'll give you back your exam, and so you'll know how you individually did. But then what if you ask me, hey, Mr. Aaron, how did we do as like a whole class? How did the entire class do? And I might say, okay, you want to know how the whole class did? Let's suppose that there was, out of 100, huh? Let me just make up some numbers. A 90, an 80, an 80, 3 80s, and 170. That's all I want. Suppose there's only 6 people in the class. So just to make my example simple. How would I represent that as a frequency chart? I would write score, and I would write frequency. And I would say, all right, how many scores were 70? How many scores were 80 and how many scores were 90? So how many 70s? There'd be 1. How many 80s?
3.
I think there's 4. If you can read my scribbles. That's another 80 there. Oh, 3. I can't count. 3. And there's 2 in the 90s. Does that make sense? So that's all a frequency chart is. It's just how frequently do those numbers appear. Okay. And then right over here, let me do a new column. And this is relative frequency. And do you know what relative frequency is? It's the percent. The percent. So in other words, what percent of all the scores were in the 90s? That's what we're going to figure out. We're going to find out what percentage of the scores were in the 90s, 80s, and 70s. That's what relative means, with relationship to all the scores. That's what it means. So you tell me, there were 2 90s out of how many total scores? 6. There's only 6 scores up there. So we would say 2 out of 6 were in the 90s, huh? 2 over 6. And then just hit the buttons on your calculator. That reminds me, by the way, are you getting those calculators? Anyway, I felt like I was doing a commercial there. All right, so now just 2 divided by 6 in your calculator, 0.333333, right? How do you change that to a percentage? How do you change a decimal to a percent? 2 places, so I'm running out of room here. 33%. Make a little more room. So I'm just showing you how to do one of these in general. Let's do the next entry. So that means 33% of all the scores were in the 90s. That's what that's saying. 2 out of 6, right? There were 2 scores that were 90 out of 6 scores total. 2 divided by 6, get the decimal, get the percentage. 33, what is 30? We talked about what percent means, didn't we? What does 33% mean? Break it down to where you can explain it to a 10-year-old. What does that mean, 33%? 33 out of 100. Are you clear on that? So we can't just say part or portion. It's specifically 33 per. Just think about the word percent. Well, how long is a century? 100 years. It means 33 per 100. That's why that cent word is there. So 33% means 33 per 100. 33 per 100 is about what fraction? If I said, hey, 33 in every 100 people like wearing hats. That's real close to what?
310.
Even simpler?
1 out of 3.
1 out of 3. If it was 33 over 99, that'd be exactly 1 out of 3, right? That's super close to 1 out of 3, isn't it? 33 per 100 is really, really almost exactly the same as 1 out of 3. So, those old commercials, they said 33 out of every 100 people surveyed prefer Crest as their toothpaste or whatever. That's like saying 1 out of every 3. 33 out of every 100. Real close to 1 out of every 3. Which is exactly what 2 out of 6 is. Right? If 2 out of 6 like wearing hats or Crest toothpaste or whatever, that's the same as 1 out of 3. Which is the same as 33 out of 100. 33%. See why that is? I want to make sure that it's real for you. Because like, what are we doing here? Are you going to really calculate tables, like make frequency tables after this class is over? No. Maybe one of you will. But probably none of you will. Maybe one of you will ever make a frequency table. But you'll read frequency tables for sure. Every one of you will read percentages and data off tables in any job you do that. And so I want to make sure you really understand the meaning. What does 33% really mean? 33 per 100. That's the portion you're saying. All right. How about the next one there? What is how many scores in the 80s? 3 scores. Again, out of 6, right? There were 6 scores total. So 3 out of 6 were in the 80s. You know that decimal, right? 0.5, move the decimal 2 places. 50%. So 50%, 50 per 100. See, that's why there's 2 zeros in the percent symbol with the line. It's saying divide by 100, isn't it? So 50% is 50 per 100, which is the same as a half. Right? If I said 50 out of every 100 people like wearing hats, it's a fancy way of saying a half, isn't it? And that's exactly what is the case with scores in the 80s. 3 of the scores out of 6, half, were in the 80s. That's why we say 50%. See how that's the same thing? Percent is just another language by which we can say a portion of something, isn't it? It's like me saying 1, uno, or 1 in some other language, right? Percent, decimal fraction are 3 languages for saying a part of something. Are you clear on that? Are you aware of that? Right? Let's say half. Well, there I already said it one way. 3 different ways. So there's half. What's another way to say half? There's the fraction language. 0.5, that's the decimal language. And finally, 50%, that's the percent language. Right? So that's my version of the glass is half full. The glass is 0.5, 1/2, or 50%. It's all the same thing, isn't it? Just want to make sure we're clear. So decimal, fraction, and percentage are 3 languages for saying a part of something, a portion of something. So how many scores in the 70s? 1 out of 6. Hit the buttons on your calculator, isn't it? 0.166666. So if I want to move the decimal 2 places to make it a percentage, so I'm going to round that. It'll round to 17%, right? Because anything that's 5 or more rounds up. So depending on how far they told us to round it. So that would round to 17%. 16.6, which rounds to 17%. So that's a relative frequency table. We have one more column, and then we're going to go back and do the homework problems. So, good so far? So relative means relative to the total, right? There's 2 scores in the 90s, but how many is that relative to the whole group? 2 out of 6, 33%. Final column now is cumulative, right? Isn't it cumulative? Yeah, cumulative. So let's do that. Cumulative frequency. Okay, now what is cumulative frequency? What does it mean to accumulate? What if I said the trash is accumulating out back? Growing, piling up, huh? To accumulate means to pile up, doesn't it? So cumulative frequency means frequencies that pile up. So in other words, it just means add them up. So 33, the first one is just itself, nothing there. But the second one means these 2 added up goes there. So 50 plus 33? 83.
Where did you get the 50 from?
Right here.
Oh,
see how I'm circling these right here?
Gotcha. That's right.
I'm just adding up those 2. Right? I'm accumulating them. I'm adding them up. And how am I going to get this bottom one down here? Add all 3 of them. Guess what all 3 added up is going to be? Yeah, because it's everything, huh? Now, if there were more scores, it wouldn't be that way, but I made a simple example. See what cumulative is then? It's just how much they accumulate. So what does this 83% here really mean? Because that's what counts, right? We're not going to make these, but we're going to read them. You're going to read a cumulative frequency chart. Do you know what that really means when that 83% is sitting there looking at you? Or do you speak his language? That's what matters. That's what you'll need to be able to do. What is that saying to you? It's saying the 80s, the 3, the 50%, the 83%. What is that? 83% what? 83%. Can you put that in a sentence that are 80 or higher? Beautiful. That's exactly it. Are we all good with that? 83% of the students got 80 or higher. Because remember, it's the cumulative. It's this category plus that category. It's the 80s plus the 90s, isn't it? So in other words, we would say 83% of the class got 80% on the exam or better. And 100% of the class got 70 or better. Make sense? The or better is the cumulative part of it. Is that all good? So see what cumulative does? We're ready to tackle the questions then. So that's how you would make one. So now they're going to give us ones that are like part made, and they want us to kind of figure out what's missing, which is more tricky than just making one. So a pushing is harder. So let's start up here. How are we going to find? I forget when I touch that screen, it does things. Anyway, let's start with that blank right there. How are we going to get that blank right there? Yeah, 240 people total. This data. So I only did 6 scores, right? 1, 2, 3, 4, 5, 6 scores. But they're saying we have 240. This is going to be a table summarizing 240 people, and they were asked how many siblings they have. Let's make sure this is making sense first off. So in other words, 54 people said they have one brother or sister, one sibling. 36 people said they have 2 siblings. 58 people said they have 3 siblings. And 49 people said they have 4 siblings. So frequency just means how many people said that. Just like over here, frequency just meant how many people got in the 90s or the 80s or the 70s. Frequency is just how many. So with that in mind, how do I find this number up here? How many people have 0 siblings? Add them all up and subtract from 240, Because they're telling us right there that this table is a summary of the data for 240 people. Does that make sense? So to figure this out right here, you subtract the total of all others from the 240. Is that good? So if we add all these up, I have no idea what they add to be. Somebody get the total of these? 197? 197. So we all have different numbers, right, when you do your homework. So these total 197. So then I'm going to take 240 minus 197, which is 43. So that must be 43. There must be 43 people in that category. Because altogether, all the categories have to total 240, don't they? Good so far? All right, how about the next spot? How are we going to figure out relative frequency right there? Yeah, right, because remember what we did over here? We just kept dividing them by 6, dividing them by 6, dividing them by 6, because that was the total number of tests, So I'm going to do the same thing here. I'm going to take 43 divided by 240. Somebody got it? I can get it. 0.17. I don't know. Did they say how many? Oh, 4 places. There we go. 4 decimal places. Okay. 0.1792. It was 16666. So I round that. Everybody okay with that rounding? It was 0.17916666. Let me just show what I did there real quick. I think it'd be helpful. So this is what I got on my calculator. And then they said round to the 4th spot, right? 4 decimal places. And so I circle the fourth place. So whenever you want to round, you just circle the spot you're going to stop at, fourth place, and look one to the right. If the one to the right is 5 or more, you go up. You know all that. 0.1792. Lastly, feel free to stop me if you have questions. I'm glad to answer. How about right there? What's the story right there? How do we find that?
Add 36 to 97.
So it's, I did, this might be confusing for you. I did cumulative frequency percentages, and you can do it that way, right? I added up percentages. So just remember, the word cumulative just means add them up. But you can add up different things. You can add up the actual frequencies, or you can add up the relative frequencies. Which one do they want? Well, you can tell there's no percentages anywhere. There's not a percentage here or anywhere. They're not adding up percentages, are they? Or decimals. What are they adding up? Whole numbers, clearly. So they want me to come over here and add up these numbers. And so the cumulative here is these three added up. Everybody see that? These three added up. So 43, 54, 36, what's that? 10, 13, 10, 133. So cumulative means to accumulate, add up. So I just added up these three, total goes right there. We good? All right, and down at the bottom, what percent of the people have exactly 3 siblings? Are we going to figure that out? What percent have exactly 3? Yeah, exactly 3. Number of siblings 3. 58 people out of 240 people, huh? Have exactly 3? 58 divided by 240. My calculator is saying 0.24166666, and then I'm supposed to move the decimal 2 places to make it a percentage. So we're looking at 24 point. I don't know how far they want me to round. They weren't really clear here, but I'll just say 17. I guess I'll just round. I guess it's 4 places still. So that's a 6. Look one to the right, round it up to 7. 24.17. We good? Questions? Oh, I should do this. Remind me, guys. I'll always forget. Yeah, that's better, huh? All right. I'm going to move. At least last week it was out there. All right, so I'm on. This is question number 3. No, 4. What was it? Question 4. All right, they're giving me ages and number of students. They say find the relative frequency for the class with lower class limit 23. Can you do that one? Rather than me. Okay, so how do we do it? The class with lower limit 23, that's this group, huh? 7. So it's going to be 7 out. Oh, yeah, that's what you guys right now. You got to know how many, huh? What do they have to be? 10, 18, 10, 20. Is it 34? So 7 out of 34. Does that make sense? And then whatever the calculator says from there. Does that make sense? How I did that? They're saying find the relative frequency. That always, you can see the percentages there. For the class with lower limit 23, that's this category. How many students were, these are the ages of students, right? We're in the range 23 to 26. 7 students out of 34 total students. I just added them up to find that out. And then hit the buttons on your calculator. I'm getting, how many places? Give your answer rounded to 2 decimals. So 0.20588. Well, yeah, first move it, then round, right? So I'm going to take the 0.2. So let me come down here. So 0.20588. And then you want to change it to a percentage. So you move it 2 places, 20.588%. You're supposed to round to 2 decimal places. So 20.59, huh? 20.59%? Is the relative frequency of that category. All is well? Is all well? Questions I can answer? So what we do, we count up how many are in the 20s. So 1, 2, 3, 4. Is that it? Oh, I guess they go in order. Oh, that's nice. I didn't notice they go in order. So 4 in the 20s, and then we just keep going. How many in the 30s? 1, 2, 3, 4, 5 in the 30s. How many in the 40s? Bless you. Yeah, just 1. How many in the 50s? 1, 2, 3, 4, 5, 6, 7, 8 in the 50s. How many in the 60s? 1, 2, 3, 4, 5 in the 60s. How many in the 70s? 1, 2, 3, 4, 5, 6. And how many in the 80s? Just 1. There we go. That make sense? Easy enough?